Have you ever thought about what's running in the background of your life? I mean, from the second you wake up to the phone in your pocket, your entire world is running on this kind of invisible operating system. It's the hidden code that governs, well, everything. Today, we're going to pull back the curtain on that system, and it's called physics.
Just think about how your day starts. It probably begins with the sound of an alarm, right? That's a vibration, a wave traveling through the air to get to your ears.
And then, maybe you stumble to the kitchen for some coffee. You've got the transfer of thermal energy, heat, that gets you going.
And finally, there's the motion of your commute. Doesn't matter if you're walking, biking, or driving, you're going from point A to point B.
Okay, so you have an alarm clock, a hot cup of coffee, and your daily commute. 3 completely different things, right? But here's the thing. They are all governed by the exact same set of rules. So what is it? What's the common thread tying them all together?
Well, the answer is physics. It's the set of fundamental principles that explains everything from sound waves and heat to motion and energy. It is, quite literally, the invisible foundation of our reality.
And look, it doesn't have to be some scary, complicated subject. I absolutely love how one of our sources puts it. Physics is just a guide that helps us make sense of the invisible forces shaping our world. It's the why behind all the stuff we see and do every single day. So let's go back to that morning coffee. The science that explains how your kettle actually heats the water is called thermodynamics. I know it sounds super intimidating, but really, it's just the official rulebook for how heat and energy work together to get things done.
And what's really cool is that this one concept is running all over your home. It's the magic behind your air conditioning, it's what's happening inside your microwave, it's in the insulation in your walls, and it's even why a cooler keeps your drinks cold on a hot day. Seriously, thermodynamics is everywhere.
And your commute? Oh, that is a daily masterclass in the physics of motion. You know when the car stops suddenly and you kind of lurch forward? That's inertia. The grip of your tires on the road? That's a constant battle with friction. Your speed is all about velocity and acceleration. And the whole time, gravity is the force keeping you firmly planted on Earth. These 4 forces are in this constant dance just to get you where you're going.
So, okay, if these are the rules for our little morning routines, what happens when we scale them up? Well, it turns out these same basic concepts are the very engine powering our entire modern world.
Let's talk electricity. Physics is absolutely fundamental to how we generate power, but it's also the key to our future, right? It's driving everything from solar and wind technologies to the innovations making all our appliances way more efficient.
Transportation is another perfect example. A car is almost completely dependent on mastering motion and friction. A bicycle, that relies heavily on things like aerodynamics and balance. But modern aviation, wow, that's a complete triumph of physics, using principles of lift, engine mechanics, and aerodynamics just to get a massive metal tube off the ground.
And what about the device you're probably watching this on right now? Your smartphone is a pocket-sized marvel of physics, and it's powered by a specific field called electromagnetism, which is basically the science of how electricity and magnetism team up to send information.
Every text you send, every call you make, every single bit of data you download, it is all possible because we figured out how to create, send, and receive electromagnetic waves. Let's be real, without physics, our globally connected world just wouldn't exist. Period. Okay, so we've seen physics in our homes and in our technology. But what about inside us? The next step is to turn that lens inward and see how physics actually shapes our very bodies and what we're capable of.
Modern medicine is pretty much built on a foundation of physics. You've got diagnostic tools like MRIs and X-rays that let doctors see inside the body without a single cut. Then you have targeted radiation therapies that treat diseases with incredible precision. And biomechanics helps us design prosthetics that can restore mobility and totally change people's lives.
But the impact of physics also shows up in our hobbies and passions. In sports, for instance, understanding projectile motion, which is just how an object flies through the air, can literally be the difference between a good golf swing and a great one.
And just look at the contrast here. The exact same fundamental understanding of forces and mechanics that helps an athlete perfect their swing is also what allows an engineer to design a prosthetic limb that moves naturally. The applications range from just improving your game to profoundly improving someone's life.
Once you start to see the physics behind everything, you really can't unsee it. It gives you this whole new appreciation for how the world works, and maybe more importantly, a much better understanding of what's really at stake.
And this is why it all matters so much. Understanding physics isn't just an academic exercise. When we ignore these fundamental rules, we get inefficiency, environmental problems, and missed opportunities. But when we apply them, that's when we unlock real progress. Everything from medical breakthroughs to new sources of clean energy.
I mean, when you really stop and think about it, the most transformative technologies of the last century, the internet, the microchip, even the awesome and terrifying power of atomic energy, they were all born from our understanding of physics.
So, the next time you heat up your coffee or ride your bike or send a text, just take a second. You're not just performing a simple action. You are actively engaging with the fundamental laws of the entire universe. The operating system is running all around you, all the time. The only question is, now that you know it's there, what will you notice next?